All right, we'll go ahead and get started. Today we're going to talk about GPS for indoor air quality. My name is Greg Jutras, and I am a product manager with HVAC Solutions. Like I said before, the company we're going to talk about is GPS, which stands for Global Plasma Solutions. The topic of discussion today is going to be the need for indoor air quality, trying to identify the opportunity in that, being able to offer solutions, and then hopefully seeing some profit, because this is truly a product in an application where I say you get the best of both worlds. You get happy customers, and you're also able to make a few dollars. So if I start at the beginning and I take a step back, when we look at indoor air quality, I can usually put indoor air quality problems into one of three buckets. And those buckets are particulate, microbials, and gases. I try to remember that by PMG. Particulate, microbials, and gases. And this is important because if you can figure out what type of problem you're dealing with, you're that much closer to diagnosing the problem and giving the customer a solution that's going to work for them. So this is a very important slide. Particulate, microbials, and gases, PMG. If you can figure out what you're dealing with, you can usually give them a solution. So what is particulate? Particulate is that dust, dander, pollen. These are generally what I call the things that are going to make you sneeze. Particulates are generally not alive, and there's a ton, I'll say a million different types of particulate. Outside of the dust, dander, and pollen. One example is meteor dust. This meteor hit, it's been about 6-7 months ago. It hit near Russia. And when I say hit, it didn't really hit the land. It didn't make its way through the atmosphere. But if you look at that red cloud there, that is meteor dust, surrounding a good chunk of the world. And that stuff is really bad to breathe. So one meteor creates a ton of meteor dust. And there's lots of examples like that. Microbials. So we just talked about particulate. Microbials. These are those single-cell living organisms. The molds, the viruses, the bacteria. These are the things that make you sick. So if particulate makes you sneeze, microbials are going to make you sick. Gases, I usually break down into two separate categories. One is odors, so the things you can smell, and then VOCs. And then when I say odors, I always bring up that while you can smell an awful lot of gases, there are certain gases that you can't smell. And the first one that comes to mind is carbon monoxide. So being in the HVAC world, we have to worry about carbon monoxide all the time, and that's a gas that you cannot smell, but it can kill people. It definitely can make them sick. So just know that while I say you can smell gases, they create an odor, for the most part that's true, but there are always some gases you cannot smell. The other side of gases are VOCs. And VOCs stand for volatile organic compound. And you're dealing with a VOC, I'll say a lot of times when you can smell it, when you smell things like glue or paint, that new house smell is associated with a VOC. And that's because in that new house there's a lot of formaldehyde, a lot of other hides too. But formaldehyde is generally used as an adhesive, and so we see it pretty much everywhere. You know, if you look around, it's in the carpet on the floor, it's on the paint on the walls, you know, ceiling tiles, it's in the wood on the desk, wood on the door, wood on the shelves. It's pretty much everywhere. So it's an issue because you can't get away from VOCs. And VOCs are bad news. I mean, if you look at it, this list here, wheezing, coughing, you know, chest doesn't feel good, it sounds like you're sick. And VOCs can make you feel like you're sick. They can also do other things like cause sore throats, sinus infection, aggravate asthma, those types of things. And then, not to scare you, but you know, long-term exposure or high-level exposure can, you know, cause things like cancer, liver damage, you know, some very serious illnesses, all because of VOCs. And then sometimes I get asked, you know, what is the difference between long-term exposure and a high-level exposure? Long-term exposure would mean, you know, you look at a factory worker who deals with some sort of chemical day in and day out for 30 years. So over the course of 30 years, he breathes in just a little bit of that VOC or chemical compound for 30 years. But at the end of the 30 years, he starts to get some kind of cancer or liver damage, something else, some kind of issue, because he breathed in that chemical at a low level for a long period of time. Now, a high-level exposure is kind of what I'll say completely the opposite. So instead of a little bit over a long period of time, you know, a different guy's in a factory and somebody spills a whole barrel of chemicals next to him, and he gets a big dose of VOCs. And all of a sudden, you know, he starts to develop issues because he breathed in a whole lot of those VOCs at once. So it's kind of like a shock versus a long period of time. So that's the difference between the two. This came out from the World Health Organization actually just a couple weeks ago. And they said that exposure to outdoor air causes lung cancer. Now that's crazy because we pretty much all breathe outdoor air. And the reason for that, they said that particulate matter, which is a major component of outdoor air pollution, was classified as carcinogenic. So that means it can cause cancer. It does eat lung tissue. So interesting report that just came out with some what I call crazy headlines. This is not working right. There you go. I think that's a little better. Sorry about that. So it said that we are trapping bad stuff in the air. There's bad stuff outside. There's bad stuff inside. It can't get out. What I like to point out is that we breathe an awful lot. We breathe somewhere between the range of 6 to 12 liters a minute. So the difference depends on what you're doing. If you're sitting at a desk like I am talking on the phone, probably much closer to that 6 liters a minute. If you're running a marathon, you're probably closer to that 12 liters a minute. You're breathing a lot more when you're exerting yourself. But what I want you to think about is if you were drinking just 12 liters of water a minute, how concerned would you be with the quality of water you were putting in your body? My guess is a lot. Inside of that air that we're breathing, and we're breathing a ton of it, it's estimated that we breathe about 2 tablespoons of solids a day. That's basically particulate, small particulates that add up over the course of a day, and we breathe a lot of it. Problem with that is people with asthma, people with allergies have a really hard time getting rid of all those particulates and all those solids that we breathe, especially over time. And when we talk about the sneeze, which we do often this time of year when everybody's getting colds and getting sick, the sneeze comes out extremely quickly. It's estimated that it's somewhere in the neighborhood of 100 meters per second. That's about 224 miles per hour. So sneezes come out really quickly. And when we sneeze, we create droplets. And droplets are what I like to call wet nastiness. So we're, always worried about being in that, I'll say 1 to 5 feet range and getting sneezed on, getting some of those wet nastiness droplets on us. But the real problem is further away from the sneeze, because these are the droplets that don't actually hit the ground. So the bigger droplets hit the ground really quickly. The smaller ones stay suspended in the air indefinitely. So what does that mean? That means you don't have to worry about it, just on the other side of the room, but you have to worry about it on the other side of the building, because these are small enough to get picked up through the return and placed into other parts of the building. The problem with these smaller droplets is that because they are so small, they're the droplets that are able to make their way into the deepest parts of the lungs and eventually make you sick. One of the newest phenomenons in the indoor air quality industry is what we're calling HTO. Stands for highly touched objects. So, this is things like doorknobs, phones, countertops, railings, elevator buttons, those kind of things. People, things that a lot of people touch. And what they study is how long do certain viruses and bacteria live on these surfaces that we're touching all the time. I'm not going to go through all of these, but C. diff, it's lasting 5 months. E. coli can last up to 16 months. So it's just kind of crazy how long some of these viruses and bacteria can live on surfaces that we touch all the time. If we talk about specific problems with buildings and homes, the first one that comes to mind is sick building syndrome. Now, this is where a person, or generally a group of people, go into work and they don't feel good. They're dizzy, they can't remember stuff, they got nose, throat irritations, maybe a cough, and they don't know why. So they leave the building, maybe it's just for lunch, maybe it's for the weekend, and they feel better. Now, I'm not talking about, a Monday morning hangover or you don't want to be there, but I'm talking about a real problem where people have these issues and it's not going away. It's over time. So sick building, if that building was to call me and we go out there and we run tests and we find that the copy machine is producing excess ozone, it's producing a lot of VOCs, right? And that is what's making this group of people not feel good, right? At that point, we've got a lot of solutions we can offer. We can move the copy machine. We can move the people. We can bring in fresh air. We can use an air purifier. So there's a lot of different options to fix that problem. My point is, that's not a sick building. That's a copy machine that's producing too much ozone, too much VOCs. That's not a sick building. Now, if I was to go into that same building, same people are not feeling good, and I can't find the problem. That doesn't mean we can't solve the problem. It just means that we don't know what the problem is. Now, that would be considered a sick building. And I bring this up because GPS has done a great job at getting rid of a lot of the sick building syndrome symptoms, and people are able to feel better and get back to work. One other problem that we run into is dirty sock syndrome. Now, this is where you walk into a building or maybe a home and it smells like a locker room. Doesn't smell fresh, that's for sure. So there's a smell, there's an odor going on. What I can tell you is that 9 out of 10 times they're going to come to you and say, hey, I've got mold somewhere. I don't know where it's at, but I can smell it. And what I can tell you is that 9 out of 10 times it's not mold. It's generally bacteria. And more specifically, it's bacteria growing on the coil. And what does bacteria do? It eats stuff, stuff that has gathered on that coil. It creates colonies, and it eats stuff. And when it eats stuff, it decomposes, is really what it's doing. And when it decomposes, it smells, kind of like a dirty sock or a locker room. My point in bringing this up is that GPS has done a great job at getting rid of dirty sock syndrome, not only the odors associated from dirty sock syndrome, but actually getting rid of the bacteria and getting rid of the root cause of the problem. So who's at risk for some of these IAQ issues? It's pretty much everybody. Is there anybody out there who doesn't know somebody who has allergies or asthma? For the last few years, I don't think I've been able to find anybody in a class that I was teaching where somebody hasn't known somebody with allergies or asthma. It's just getting too prevalent, and children are getting it a lot more than previous generations. So the opportunity, of course, is people with allergies and asthma, but really it's people in general. People don't want to get sick. People don't want to smell odors. And allergies and asthma are still a factor. So if I bottom line this, bad stuff is in the air. We're starting to see it's bad outside, and the indoors a lot worse. We're trapping bad stuff indoors. So if we don't do something to get rid of the problem, our lungs have to get rid of the problem. They're kind of like a filter. So let's help them out a little bit. If we talk about what I'll call older technology, UV lights have been used, I don't want to say forever, but for a long time. Actually, first used in the 1800s. In the 1950s, started being used a lot more in HVAC. UV lights have done a great job at cleaning a specific object, in this case a coil, but it also does a great job at cleaning medical utensils, those kind of things. What UV light does not do very well is it doesn't travel, so it doesn't go very far, it doesn't go very fast, and that's why you need a long exposure time. But if you give it that long exposure time, it does a great job. And the reason we need those long exposure times is because if you go just 3 inches away from that UV bulb, you've lost almost 90% of the effectiveness of that UV light. And again, UV lights do a great job, but they do take quite a bit of time to do what they need to do. It's not instantaneous. Here's a picture of UV lights if you were trying to clean every square inch of a coil. And in my time, I don't think I've ever seen more than 2 shining on a residential coil. So the product we're going to talk about is GPS. Again, it stands for Global Plasma Solutions. They're based out of Savannah, Georgia. So it's a U.S.-based manufacturer. What this product does is it creates bipolar ionization. So it's creating high voltage of both polarities. So we've got positive and negative, and we're charging hydrogen and oxygen ions. That process is known as plasma, or we call it bipolar ionization. So when I talk about it, I think of plasma as kind of the cloud. Not the cloud where we're storing a bunch of data, but a cloud where things are passing through it and going away. So bipolar ionization is kind of the process, and we're creating plasma, which I like to think of as the cloud. So what does bipolar ionization do? Well, we're killing a lot of stuff. We're killing mold, bacteria, viruses. We're getting rid of odors, and we are reducing static electricity. So I want to say almost all the problems we've been talking about can be solved with the GPS device. So we get asked all the time, what happens when that ion collides with a virus or a gas? Well, what we're doing is converting it to a friendly gas. So we're turning that objectionable odor into nitrogen, oxygen, carbon dioxide, or water vapor, things that occur naturally. So I like to use words like, hey, we killed that germ, but really what we did was we turned it into oxygen. All right, so residentially speaking, the unit we use 9 out of 10 times is the 2400. 2400 stands for 2400 CFM. So this guy here, and if you look at the size, is literally 2 inches by 2 inches. So it's a small unit, and it's good for up to 2400 CFM. So that's most residential applications. It is voltage specific. So there are 3 different options, 24 volt, 115, or 208, but each one is a separate unit. There's a 24 volt unit, there's a 115 volt unit, and there's a 208 volt unit. So a lot of options, but you have to pick which one you want. Because of its size, these units are able to go pretty much anywhere. We've been putting these in P-TACs. We're even putting them in room air conditioners, and there's no space in there. So no problem to get this in any kind of fan coil or duct-free split. Unit ventilators, they can pretty much go anywhere. We haven't found anything yet where we couldn't fit a unit. The other nice thing about these units is that there's nothing to replace. So there's no bulbs, there's no cells, there's no replacement tubes, where you have to go back there annually or biannually or maybe even every 3 years. So it's kind of what I call a one and done. You're going to install this thing once, and the good news is you never have to go back. The bad news is you never have to go back. So depending on which way you look at it, it's nice because homeowners and business owners are happy that they only have to pay for it once, and there's nothing to replace ever again. But on the same token, that's the bad news because you're not selling a bulb or a cell every few years. The install on these things is extremely simple. So on most indoor air quality devices, we're going to install it in the plenum. This one is different. we are installing this in the blower housing. So I'll say that again. We are installing this in the return near or on the blower housing. And then you're just, it's literally one zip screw, and then you're going to get voltage to it. When we first started, we were selling more 115 volt units, but that has switched over to where now we're selling a lot more 24 volt units for whatever reason. So one screw in the blower housing, and then you get your voltage to it, either 24, 115. If you had a fan coil or something like that, you could do 208. But we're not seeing those as often as the other ones. So as you can see here, this is the smaller unit. We took a picture of this because this is actually a unit ventilator, where typically it's hard to get indoor air quality products into. Right there on the blower housing, a short zip screw, and then power to the unit. So it's not a difficult install at all. So before, this guy takes care of odors, and we are able to break down all gases that have a electron volt potential below 12. So I get asked all the time, what does that mean? Well, a lot of chemical compounds and VOCs in gases, all chemical compounds are going to have a electron volt potential. If that electron volt potential is less than 12, we're going to get rid of it. What that means is we're not messing with things like oxygen. So we don't mess with the air that we breathe. But they do a great job at getting rid of, you know, some of the common ones are ammonia. You know, we see ammonia in the air all the time. We see formaldehyde. That's that, you know, poster child of VOCs everywhere. So we're doing a great job at getting rid of those, but at the same time, we're not messing with the air that we breathe. Here's a example of what happens. You've got an ammonia molecule that goes through that plasma field. So we create ions. It creates kind of a cloud in the space. Ammonia molecules go through. Sorry. And it's turned into things that we can easily breathe. Here's another example without the cartoons. Formaldehyde goes through that plasma field, and that formaldehyde will turn it into carbon dioxide and water vapor. Particulate. Now, here's the other benefit to this product. While we can't kill particulate because they're not alive to start with, what we are able to do is change the electrical charge of the particulate, which means they attract to each other and then they get bigger. So with bigger particulate, we are able to make the filter that's in there more efficient. So here's a quick diagram. The ions that are positively and negatively charged make the particulate attract to each other, and therefore they get easily trapped into the filter. So here is my grade school drawing of what we're doing. We've got a GPS unit mounted in the return of the unit. You can see your filter there. We're creating positive and negative ions, millions of them per second. So I'm calling them Pac-Men because it's just easier for me. Now, blower kicks on, and we send the Pac-Men through the ductwork and into the space. You see some of them get, you know, trapped on the coil. We're doing a good job at cleaning that coil, making sure there's no bacteria or viruses growing on there. And then some are going to actually come back and start cleaning the filter and make their way through. But if you can see my little particulate diagrams in this space, what happens there is these ions automatically go to the particulate. The particulate then attract to each other, so they become a bigger particulate. So you had 2, 3 smaller particulates. They attract because of the positive and negative ions, and then those bigger particulate have no problem getting stuck in the filter. So that's my grade school drawing of, kind of the process. So not only are these guys out in the space taking care of VOCs, odors, viruses, bacteria, but they're also helping capture more particulate. Okay, so with the particulate, like I said, we're attracting, they're getting bigger, they're getting caught on the filter. With mold, bacteria, and viruses, it's a little bit different. The ions surround the virus, the mold, the bacteria, whatever it is, and then what we're doing is robbing the virus of the hydrogen. So it's literally ripping out the hydrogen from that cell, whatever it is, and it's not able to survive. So it's very similar to other indoor air quality processes, but instead of ripping out like a electron or a neutron, we are ripping out the hydrogen. So that cell is not able to live anymore. Here's kind of a picture of what it looks like. And then without the hydrogen, it cannot live. And I like to say that it's killed, but it's really rendered inactive. And it becomes a less objectionable gas. UL 867. I get asked all the time if this product creates ozone. And this is one of the only products that I know of that has actually passed the UL 867 test to show that it does not produce any ozone. So it is UL certified to not produce ozone. So it is not a ozone generator, and it does not produce ozone. Every year, there's some kind of a new bug. Something that the media grabs a hold of, and starts running with. Are we going to have enough vaccines? Is this and that? There's always something going on. A few years ago, it was H1N1. We've seen hospitals adding wings for the H1N1 outbreak. It was on the news. It was everywhere. And the GPS product is third-party tested to do a great job at getting rid of H1N1. The norovirus and the rotavirus. If you've had young kids recently, this one hopefully is not common to you. But this is where the kids get sick, and long story short, you are changing diapers, every 15 minutes for a couple of days until you decide to take them into the emergency room because you're scared they're going to get dehydrated. So it's a really nasty bug. Generally goes after small children, infants, and there's a lot of cases of this thing. So it's bad news. And the GPS product does a great job of getting rid of the norovirus and the rotavirus. E. coli. So this is food poisoning. You can pick it up at a lot of different kind of places. But what happens is 15 minutes, GPS is 99.68% effective at getting rid of E. coli. MRSA. So this is a bacteria and this is a surface-borne bacteria. So this is, MRSA is really staph infection on steroids. Excuse me. So what that means is you see this in a lot of hospitals. You see this anywhere where there's mats, where there's sweating, wrestling, gymnastics, locker rooms, anywhere where there's those type of activities. You know, this is the one where you might go into a hospital for some knee surgery, and you end up dying because you got MRSA. And let me ask you this. If you got some sort of an infection, what do you normally do to get rid of it? Well, answer. You normally take antibiotics to get rid of, you know, like a sinus infection or something like that. But if you look at MRSA, that second word there is resistant. What does that mean? That means it doesn't care if you give it antibiotics. It doesn't care. So there's really, it's exceptionally difficult to get rid of. And that's why people end up dying, because they can't get rid of this thing. And the GPS is, you know, over 96% effective at getting rid of MRSA. As you can see, it takes a lot of forms and it attacks a lot of different places on the body. Nasty little bacteria. Tuberculosis. Tuberculosis is a bacteria that affects the lungs. So you feel sick. It generally goes after people who have some sort of weakened immune system. And this is an extremely difficult bacteria to get rid of. And GPS does a great job at controlling tuberculosis. As you can see, there's 69% kill rate on tuberculosis. C. diff. So C. diff is one of those, I'll say, new bugs that we're hearing about, and you're hearing an awful lot about this if you deal with nursing homes or in hospitals. So this is a bacteria that we see an awful lot, like I said, in hospitals, in nursing homes, that kind of thing. And you feel sick. It's more of a stomach type of sickness, but it lasts such a long time. You're going to see dehydration. You know, we're talking, you could easily be in the hospital for weeks, if not longer than that. And it's so nasty that, you know, if you're able to survive being sick for that long, becomes, you know, life-threatening to where people could actually die. So this is one to watch out for. I'm calling it kind of a super bug. That C. diff is bad news, and GPS does a great job at getting rid of C. diff. This is an air advice test on a small office building. And you can see that VOCs are kind of high to going off the charts. And the red circle is where a GPS unit was installed. You know, almost immediately starts bringing down the VOC level. And then a week later, I mean, well below any kind of actionable VOC level within a week. So no action necessary. You know, everything's fine in that building. All right, ASHRAE 62.1. I'm going to talk about this because we get people who are outside of Chicago on webinars, but just know that if you are an engineer here in Chicago, this does not apply to Chicago. It's one of the only places in the country where you cannot use this. But if you do work anywhere else, this is an accepted practice. So what we're talking about is the IAQ procedure. And the idea is that we're going to reduce the amount of outside air needed into a space. The reason being, why do we bring in outside air? Well, to dilute the pollutants. If you have an IAQ device that can get rid of the pollutants, you don't need as much outside air. So that's the idea behind it. So GPS uses ASHRAE-based, what I'm going to call IAQ strategies. So they're not taking anything for granted here. They're taking everything right out of ASHRAE to calculate the ventilation rate. Here's an example of what it looks like. It's basically a Excel spreadsheet with drop-down menus. Instead of doing it for a building, though, you're going to do it by zone. And it's going to automatically plug in the pollutants suspected to be in that place and what the GPS can do to get rid of it. So there's really no calculation on your part. It's already done for you. Bruce Longino is a engineer. He works for a carrier distributor down south, and he wrote this article for the HVAC Insider. The title of it is Bipolar Ionization is Not a Mental Disorder. Some people might argue that. But he's quoted as saying that in this engineer's opinion, this is one of the best technologies to come along in many years. So they've had a lot of success with it, and we are starting to see a lot of success with it. Here's the International Mechanical Code, and where it shows the exception to where you can use the IAQ procedure. This was a test, and basically showed that after installing the GPS, the pollutants indoors were comparable to those found outdoors. So third-party tested to where the GPS did what it said it was going to do. So when we're looking at outside air reduction, basically this is a classroom, and we're going to say, I'll say 15 CFM per person. Means we have to bring in 450 CFM of outside air. The penalty for bringing in that much outside air is going to be just over 3 tons. So you got to heat it, you got to cool it, but that's the penalty. If we look at that same classroom and we install a GPS device, we take it from 15 CFM down to 5. We're bringing in 150 CFM, not the 450, and your penalty is only 1 ton. Sorry, I paused something there. Sometimes I have people say, well, you know, I do that already. I use an ERV. Say, great, use an ERV. So we're still bringing in 450 CFM. We're capturing 70% of that energy. So your penalty is 1 ton. Say, great, use that ERV, but also use a GPS device. So instead of having a 1 ton penalty, we're down to 0.3 tons. So depending on the load of that room, you may not have to do anything at all to address the extra 1 ton of cooling or heating. So, you know, not only are you downsizing the amount of outside air you have to bring in, that could mean less ductwork, less electrical, less steel. You know, you're affecting a lot of other things that we don't always look at. Here's an example. There's a school in Atlanta, 120,000 square feet, saved them in the neighborhood of $300,000, but because we were keeping coils clean and other things like that, it saved them $48,000 a year in energy. So save them cost-wise up front because they're able to downsize the chiller, and then it was able to save them monthly after that. So lower first cost, improved energy savings, you get better IAQ. We're getting rid of the bacteria, viruses, mold, odors, and then we're even helping with particulates. So it's really a great system. Residentially, we're looking at 2 units. The one we use 9 out of 10 times is the 2400. That's the one on the right. It's a black unit. It's kind of got the 2 emitter points sticking out of it. The one on the left is a 1200. It's a 1200 CFM unit. We're using those mainly for duct-free splits and PTACs because they're extremely small. They're even smaller than the 2400, which is hard to believe. And then both of those units are voltage specific, so you got to choose which voltage you want. Commercially, we do a unit what we call the I-bar, and this guy's literally about 1 inch wide. I'm sorry, 1 inch wide, and then it's custom length depending on the size of your coil. And these can be custom up to about 9 feet long. It comes with a, call it a power head, so you can do more than one of these on one coil. And these ions shoot out about, I'm going to say 5 feet. So you can do a 5-foot coil with one, and you can do up to a 10-foot with 2 of them. 300 and 600. These are a little bit different. They do have the GPS technology in them, but these are kind of, I'll call them freestanding units. The one on the right kind of, sits in a corner. It's a freestanding unit. The one on the left is basically a ceiling cassette where it's going to go into a drop ceiling. We're using these mainly for places with a lot of smoke, where there's a room that needs a lot of special attention. This guy's not only going to have the GPS technology, but it's also going to have HEPA filtration technology and some UV lights with it. So we're using these for cigar shops and that kind of thing. But what I want to point out is while the GPS technology does not have anything to be replaced, when we add in HEPA filtration and UV lights, those do need to be replaced. And I'll say annually, those would have to be replaced. The RN, this is a commercial version of the 2400. It's got longer emitter points, so we can get through insulation and those kind of things. And it's also got outputs to where you can talk to a building automation system if you wanted to do that. So here's the quick breakdown on how GPS compares to other IAQ products on the market. Again, we're not creating any ozones. There's nothing to replace. And it's an extremely small unit, so it fits just about everywhere. When we look at UV lights, beautiful thing is it doesn't have to be replaced. We're still killing mold, bacteria, and virus. We're not only just killing them on the coil, we're actually killing them in the space. So we're talking about the doorknobs and the desktops, where people are actually at. We're getting rid of odors. We're helping with particulate, and there's no mercury. So some UV lights still contain mercury, and for whatever reason, that's not a good thing. And then when you say fragile, you could easily keep a GPS unit in the back of a truck, and it's not going to get damaged, whereas a UV light is questionable. Just a couple quick testimonials. This mechanical company put these into a homeless shelter. And this homeless shelter, would have 50, 60 people, at any given time. And once it was put in, I mean, there was no smell, and they were extremely happy with the product. So I was able to take care of the homeless shelter smell. Here's a retirement community, where they were having some odor issues, and you can see within 1 day the odor was dramatically reduced. Within 2 days there was no odor. So it did a great job. Here's a local one from Chicago. Say my friend Pete put this into a residence, where they had a couple dogs that they kept in I'll say a smaller room, and they smelled it every time they walked into the house. They smelled the dogs, and they were able to get rid of that dog smell and make a happy homeowner. Here's a few, I'll say higher end users. What I want you to notice is some of the casinos, some of the daycare centers, those kind of things. But it's done a great job at a lot of those facilities. Not only to get rid of just outside air, but getting rid of odors and contaminants. That's all I got. If you have any questions, I'll stay on for another minute or two to answer them. If not, I really appreciate your time. Thank you so much.